The direction cosines of a line satisfies two relations, lambda times L plus M equal to N and Mn plus Nl plus Lm equal to 0. Now satisfying two simultaneous equations which is second degree, there will be two such lines which satisfy these conditions. Now what is the requirement? If the two lines which are obtained from these two system of equations are perpendicular to each other, then the value of lambda is required, right? What is the first equation given? Lambda times L plus M is equal to N. Let's treat this as an equation 1. And what is the second equation given? M into N plus N into L plus L into M equal to 0. Let's treat this as an equation 2. Now when we consider the second equation, N times L plus M plus L into M equal to 0. Now this L plus M value, let us replace from this equation 1. Then what will happen to that equation? Let's replace the N value from this equation 1 into this equation. Then it becomes lambda times L plus M whole square plus L into M equal to 0. Let's convert this into a quadratic equation. That gives us lambda times L square plus lambda times M square plus 2 lambda plus 1 times L into M equal to 0. Now, what happens if I divide this equation throughout by M square? Lambda times L by M whole square plus 2 lambda plus 1 times L by M plus M square by M square would be 1 equal to 0. Now look at this third equation which we are writing. That's a quadratic equation in L by M. Let this quadratic equation has two roots, L1 by M1 and L2 by M2. Then as L1 by M1 and L2 by M2 are the roots of this equation, can we write the product of the roots, that is L1 by M1 into L2 by M2 will be equal to lambda by lambda, which is 1. So what did we get a condition from here? We got L1 into L2 equal to M1 into M2. We got a relation in terms of the two possible lines direction ratios L1, L2 and M1, M2. Then again considering the second equation once again, Mn plus N into L plus L into M equal to 0. Can we rewrite this equation as M times L plus N plus L into N equal to 0. So can you tell me what is M value from here? Yes, M value would be minus Ln by L plus N. Now this value of M, again when we replace in the first equation, what do we get? We get lambda times L. In place of M we are replacing minus Ln by L plus N plus Ln minus N equal to 0. Now again when we convert this by taking LCM into quadratic equation in L and N, what do we get? We get lambda times L square minus L into N minus N square equal to 0. We got a second degree equation in terms of L and N. What happens if we divide this equation throughout by N square? Yes, this becomes lambda times L by N whole square minus of L by N minus 1 equal to 0. How is this equation? The equation 5 is a quadratic in L by N. Then this equation will have two roots. One is L1 by N1 and other one is L2 by N2. Then from this equation, what is product of the roots? L1 into L2 by N1 into N2 will be equal to minus 1 by lambda. So this we will treat it as a condition 6. This will also relate L1 and L2 with N1 and N2, the DRs of the two lines required. Now the most important condition is the two lines which are represented by the DRs of the system of equations are perpendicular to each other. So what is given condition to us? The third condition, these two lines having DRs L1, M1, N1 and L2, M2, N2. These two lines are perpendicular. Now when do we have two lines with DRs L1, M1, N1 and L2, M2, N2 as perpendicular? That is possible if L1 into L2 plus M1 into M2 plus N1 into N2 is 0. Though we don't have the exact value of L1 into L2, similarly M1 into M2 or N1 into N2, but we have the proportionate values of L1 into L2, M1 into n2 and n1n2. So let us replace those values. That gives us 1 plus 1 minus lambda equal to 0, or in other words, the required value of lambda happens to be 2, which is present at option A with us.